In this video, we build clean, schematic visuals to understand why Japan and Taiwan are such active mountain belts. And we finish with a crisp comparison to Mediterranean origins like the Alps, the Apennines, and the Hellenides. Our drawings are conceptual and not to geographic scale. First, Japan. Japan sits at a convergent plate, margin dominated by subduction. To the east, the Pacific Plate dives westward under northern Honshu and Hokkaido along the Japan Trench, while to the south, the Philippine Sea Plate subducts under southwestern Japan along the Nankai Trough. A classic forearc, arc, and back arc system forms, trench and accretionary prism on the ocean side, a volcanic arc inboard, and a back arc basin to the west, like the Sea of Japan. Central Honshu hosts the Japanese Alps, a zone of crustal thickening and rapid uplift, influenced by collision with the Isobonin arc and internal faulting. GPS shows vertical uplift of about 3 to 5 millimeters per year. Japan is also intensely seismic and volcanic. The 2011 Tohoku event, magnitude 9, ruptured a long segment of the subduction interface and drove large coastal shifts and a devastating tsunami. Now Taiwan. Taiwan is a textbook arc-continent collision. South of Taiwan, the Philippine Sea Plate subducts along the Manila Trench, but at Taiwan's latitude, the buoyant Eurasian continental margin collides with the Luzon Arc. This concentrates shortening across the island, with a west-dipping megathrust beneath the western foothills, backthrusts in the east along the longitudinal valley, and a rapidly uplifting mountain core. Convergence is very fast, roughly 90 millimeters per year, and uplift commonly 5 to 10 millimeters per year, with extremely high erosion driven by heavy rainfall and frequent typhoons. Key deformation signals today. In Japan, locked subduction interfaces load elastic strain that is released in megathrust earthquakes. Inland, shortening and strike-slip faults localize in central Honshu, and the Japan Alps rise at 3 to 5 millimeters per year. In Taiwan, shortening of about 30 to 40 millimeters per year across the belt thickens the crust. Vertical uplift of 5 to 15 millimeters per year is measured in places, and extreme rainfall keeps erosion rates among the highest on Earth. How do the Mediterranean origins compare? The Alps are a continent-continent collision with modest present convergence and uplift about 1 to 3 millimeters per year, plus post-glacial rebound contributions. The Apennines are unusual active extension along the crest from slab rollback and back arc processes, with uplift around 1 to 2 millimeters per year in places. The Hellenides include the fast Hellenic subduction system and back arc extension across the Aegean, with 1 to 2 millimeters per year uplift locally, for example at the Corinth Rift footwall and parts of Crete. Very compressed numbers at a glance. These are representative maxima or typical present-day values. Japan Alps uplift about 3 to 5 millimeters per year, erosion roughly 2 to 3 millimeters per year. Taiwan uplift commonly 5 to 10 millimeters per year, erosion 4 to 8 millimeters per year. Alps uplift 1 to 3 millimeters per year. Apennines roughly 1 to 2. Hellenides around 1 to 2 in uplifted forearc and rift footwalls. Summary. Convergent margins build mountains by stacking crust and adding magmas, while climate-driven erosion trims relief. Japan mixes subduction and arc collision, producing a complex transpressional mountain system. Taiwan is a narrow, fast, arc-continent collision where uplift and erosion run neck and neck. The Mediterranean belts, though slower, still grow and collapse in places due to rollback and extension. The key is the balance among convergence, uplift, and erosion through time.